As you saw in the title, can you generate electricity with just a lemon? It's not magic, it's pure and simple chemistry. Well, look at this calculator. I took out two little wires here where the battery used to be, and of course now that it doesn't have it, it doesn't work, it doesn't function. But well, just to show you that the calculator works, I'm going to put a regular battery, one of these 1.5 volt ones, here on the wires. And you see that it starts up, it works. But what's curious is that with a lemon, look, it also works. It's working with a battery made from a lemon. I'm generating electric current with just a lemon. And well, yes, I know. Did you see the electronics over there? Well, I'll tell you what it's about. It's a very, very simple circuit. It's an electronic circuit known as a Joule thief. Basically, it's a high-frequency oscillator that transforms the voltage, which is very low, just about 0.9 volts, what the lemon battery supplies, and it transforms it into a voltage of around 1.5 volts, which is what's needed for the calculator to work. I'm going to show you how to make the circuit, but don't worry, because at the end, I'll show you how to make the calculator work without this circuit, directly with the lemon batteries. Joule's thief is made with any transistor. I used a BC 548, which is a general-purpose NPN transistor. You can also use a 2N2 1222 or any other NPN transistor. You also need a toroid. A toroid is one of these rings made of a ferromagnetic material. I took it from an old PC power supply, but you can also get it from a power cable. Check out these bumps. They usually have to prevent interference. Do you see this? Well, inside these plastic parts, there are toroids like the one I used. You wind it with two wires together, passing both wires at the same time, just like you're seeing here. You can do it with enameled wire, copper, or with cable. Like in this case, the length of the two little wires will be about 50 centimeters. This isn't very critical either. I took these thin little wires from a network cable, which you can see has several pairs of different colors. We twist them, make sure they go in there. It's not critical, like I said, whether it's 10, 15, or 20 turns, it's not a problem. We will also need a resistor between 1,000 ohms, which would be brown, black, red, up to 2,200 ohms, which could be red, red, red. That gives 2,200. Any value between those two values will work. We will also need a 1-in-4, 148 diode for rectification. Are these the little red ones? I also took them from an old power supply and an electrolytic capacitor of 1 microfarad 10 volts. Is this one good? You connect everything as shown in the diagram, and in this part of the circuit you see here, which is the one with the transistor, that's the oscillator part, and the part with the little diode and the capacitor is the rectifier. They rectify the alternating current that comes out of the oscillator, turning it into direct current so the calculator can work. To make the lemon battery, we need the following. Obviously, a lemon and a piece of zinc sheet. Look, I cut two strips about 10 centimeters long and 0.5 centimeters wide from this old gutter. And we will also need a copper wire. It can be like this, a wire, a thick one. This should be about 2 millimeters in diameter, also about 10 centimeters long. You can also do it with a regular cable. You strip it, twist together the fine wires inside, make them into a single strand, and you can use that. that will also work perfectly fine for you. And here comes the truth about the blunder I mentioned in the title to get you to watch, because otherwise you wouldn't watch my videos. The lemon is not what generates the electricity. That's wrong. That's what the title says. It just acts as a vehicle for the electrons to travel from one electrode to the other. The real protagonists here in the battery are the metals, zinc and copper. Zinc is a metal that tends to give up electrons. It wants to get rid of them, while copper is hungry for electrons. So, this one wants to get rid of them, and this one wants them, give them to me, which is a kind of perfect symbiosis. And that combination is what gives us the volts, the energy, the one that transforms from chemical energy to electrical energy. If they had magnesium instead of zinc, we could get higher voltages than what zinc and copper give us. There is a greater redox potential difference between them. In simple terms, not all metals release or attract electrons with the same strength. The key is the difference in ambition for electrons. In the different metals that we combine, in this case with zinc and copper, we have a potential difference, a voltage of around 0.95 volts. Look, we're going to measure it. If we used magnesium instead of zinc, we would have values here that range from 1.5 to 2 volts. So notice the difference depending on the metals we use. The lemon, as I mentioned before, only provides an acid, which is citric acid, and it has the property of ionizing the liquid inside the fruit, and it acts as a vehicle for those electrons. The voltage we get from just 1/2 of the lemon is sometimes not enough to power the calculator. That's why it's necessary to use the Joule thief if we're only using 1/2, like in this case we're seeing. However, if we use 2/2 of the lemon in series, that way we add up the voltages. And will we be able to turn on our calculator without the electronics, like I was saying before the electronics? I showed it to you to demonstrate that it's a very versatile circuit and that it works very well, but you can also do it without the electronics. Let's see if that's true. And we could also use this same thing to run an alarm clock. But if we wanted more voltage, for example, to light up an LED, would it be necessary to connect more lemons in series? To connect the 2/2 of the lemon in series, you must join the positives with the negatives of each half. This way, the voltages add up. Well, here we see the 2/2 connected in series, the bridge that joins the 2/2. Notice that it is made up of a copper part joined to a zinc part. They are placed this way, and the calculator turns on without any electronics. Obviously, don't expect this battery to power devices that require a lot of current, because it really supplies very little current, even by putting several halves of lemon in. It's a typical electrochemistry experiment and shows how certain materials tend to give up electrons, while others are eager to receive them. And we can take advantage of that to make electrochemical cells. That's all for today. I hope you enjoyed the experiment. Do it at school if you want to get a good grade. Do it. It's super simple, and you'll look great. If you liked it, give it a like, share the video on your social networks, and subscribe to the channel by clicking the bell to get notifications when I upload new content. You can also join, and in that case, I'll add you to a WhatsApp group where the premium members are. Thank you so much for watching the video, and see you next time, God willing.